Now let's take a look at some different routing protocol characteristics. Keep in mind that routing protocols are used by routers to exchange information or updates about the networks that those routers know about or have learned about. However, routed protocols are the actual packets that are being routed by the routers. There are three types of routing protocols: distance vector routing protocols, link state routing protocols, and hybrid routing protocols. Distance vector routing protocols, the two things to keep in mind about distance vector. One, distance vector routing protocols send out periodic updates. And secondly, those updates contain the entire routing table. Just imagine if every time you and a friend talked, you introduced yourself, you told everything about yourself, you told everything that you did yesterday, and you told everything that you did that morning. And then the next day you meet again and you introduce yourselves, you tell all about your families, you tell everything about yourselves, you tell everything you did the day before, and you tell everything you did that morning. This is sort of what distance vector routing protocols do. They send these periodic updates, and every time these updates come out, it's the entire routing table. It's everything that the router knows. However, link state routing protocols operate differently. Link state routing protocols only send changed base updates. Instead of these periodic updates, they only send updates when there's an actual change. And they only send information about the change. So they're the exact opposite almost of the distance vector routing protocols. Hybrid routing protocols utilize some of the advantages of distance vector routing protocols, such as some of the distance vector routing protocol metrics, but then they use changed base updates and they don't send their entire routing tables. They only send the changes themselves. Those are your different types of routing protocols. Now, let's talk about another topic with routing protocols called the autonomous system. An autonomous system is a collection or grouping of routers under a common administrative domain. You can compare an autonomous system to an ISP. As a matter of fact, it's basically one of the main operations of autonomous systems. You've got this autonomous system, this ISP, with all of its customers' routers, and they exchange routing updates using one particular routing protocol. And then over here you've got another ISP, and their routers use a different routing protocol. Over here at ISP 1 we use RIP to exchange updates between the different routers in that autonomous system. Over here you've got another autonomous system with this second ISP, and they're using OSPF within their autonomous system. These routing protocols that are used inside the autonomous system, these are called IGPs, Interior Gateway Protocols. Examples of interior gateway protocols used inside the autonomous system are RIP, IGRP, EIGRP, and OSPF. When one autonomous system needs to communicate with another autonomous system, we use what's called an EGP, an Exterior Gateway Protocol, to communicate between autonomous systems. An example of an EGP, or an Exterior Gateway Protocol, would be BGP, Border Gateway Protocol. Another very important concept to consider with routing protocols is the concept of administrative distance. Administrative distance defines a trustworthiness factor for your router to decide between two routing protocols that report the same information. Let's take a look at this. Say, for instance, router A has two routing protocols operating on it. Here's router B, C, and router D. We've got network 20.1.1.0, and over here we've got network 10. Router A has RIP operating here between router A and router C, and between router A and B, they're exchanging updates using IGRP. Both of these routing protocols report that they have a path to the 20 network. RIP says I can reach the 20 network going this way, and IGRP reports back to A and says I can reach the 20 network going this way. Router A has to have a mechanism to decide between whether to use the RIP given route or the IGRP route, since they're both going a different direction here. Administrative distance is the method that router A will use to choose between RIP or IGRP. The lower the administrative distance, will be chosen. RIP has an administrative distance of 120. IGRP has an administrative distance of 100. These administrative distances are pre-configured defaults inside the iOS software, so you and I don't have to set these. RIP has a higher administrative distance than IGRP, so therefore, since IGRP reports that this path should be taken, router A will choose the IGRP path since the administrative distance is lower. Let's look at a chart comparing default administrative distances. The administrative distance of RIP, notice, is 120. The administrative distance of IGRP is 100. The administrative distance of EIGRP is 90. The administrative distance of OSPF is 110. But notice the administrative distance of the directly connected routes and the static routes. The static routes administrative distance is 1, whereas those that are directly connected has an administrative distance of 0. So that gives us some basic comparison points for your different routing protocols. Remember, distance vector routing protocols send periodic updates of their entire routing tables, whereas link state routing protocols only send change-based updates and only information about that which has changed. Autonomous systems and administrative distances are a couple of other concepts that are important to remember when comparing routing protocols.